All right, go and take your homework out if you would, please, and your textbooks. Open to page 499. For homework, you did the homework, numbers 1 through 11, and also 20 and 21. So you were practicing with some review concepts, some evaluation, some writing proportions like we practiced in the last lesson. Also practiced with what we talked about yesterday, factoring out a common monomial factor. So let's see how we did on those. And you did it on paper, okay? And Joshua also on paper. That's it right there. Excellent. All right, let's go and take a look at the 1 through 8 first of all. And what did you get when you factored 11j plus 11k? Joshua?
11 times the quantity 1j positive 1k.
Good. 11 times the quantity j plus k. Number 2, Lana.
I'm a little confused because
What was your answer?
my number 2 is I see. 9 times the quantity of 1v positive 3w.
Good. 9 times the quantity v positive 3w. Number 3, Joshua.
3 times the quantity 4p squared positive 5p negative 2.
Good. In each one of these cases, we have a common numerical factor, didn't we? 3 times the quantity 4p squared positive 5p negative 2. Number 4, we had a common variable factor, Lana.
Y times the quantity of 10p positive 7q positive 5z.
Good. She pulled out or factored out or divided out, remember, the y from everything. Y times the quantity 10p positive 7q positive 5z. Number 6, Joshua? Or number 5, Joshua?
H times the quantity 6h negative 35.
Good. H times the quantity 6h negative 35. Number 6, Lana.
5 times the quantity 5c squared negative 2cd negative 3d squared.
Perfect. 5 times the quantity 5c squared negative 2cd negative 3d squared. Number 7, Joshua.
G times the quantity 6g squared positive 3g positive 7.
Good. For number 7, G times the quantity 6g squared positive 3g positive 7. And number 8, Lana.
M cubed times the quantity m cubed n negative n cubed positive n to the 6th.
Great job. She got the common monomial factor of m cubed, which is the most she could take out. Again, don't settle for m or m squared when you can get an m cubed out. And then left her with the quantity m cubed n negative n cubed positive m to the 6th. Perfect job. Were you both perfect on all 8? Outstanding. Number 9, just evaluating when h is 2k is negative 4, Joshua.
Negative 44.
Great job. Negative 44. Number 10, Lana, evaluating when w is 4, x is 3. 1. And number 11, Joshua.
Negative 180.
Ooh.
Positive 60.
Oh,
What?
let's take a look at this one. All right, we have an rs squared positive r squared s. Now let me ask you, right here, what's being squared, class?
The R.
Just the r. Right here, what's being squared, class?
The S.
Just the s.
Wait.
So we've got a negative 4 times a 5 squared plus a negative 4 squared times a 5, right? Now, what does squared mean, class? It means...
Double, like 5 times 5.
Right, times itself. Multiplied by itself. There you go. So 5 squared means 5 times 5, which would be 25. That gets squared first, then multiply by the negative 4. You don't multiply first. If we were to drag this over here, we can actually see the order of operations poster. Remember, exponents before you multiply divide. So 25, then multiply that by the negative 4 is going to give us
Negative 100.
negative 100 here. Right here, we have to square first. But it's negative 4 times negative 4 gives positive 16. Multiply that by 5 gives us positive 80. And we're going to combine the negative 100, now finally adding the negative 100 plus the positive 80.
Negative 20.
Negative 20 should have been our answer for that last one.
I forgot, I wrote negative 4 times 5, and I didn't put the square.
You forgot the square right here or right here?
Right.
The first one. And Joshua, did you forget the second square?
No, I got both the squares. I just had the wrong sign, I think.
Okay, all right. Let's drop down now to the proportions. It says Susan makes $84 in 8 hours. How much money will she make in 40 hours? And what was your proportion, Lana?
Okay. $84 over 8 hours. And then X over 40 hours?
Good. $84 over 8 hours equals X dollars over 40 hours. Of course, we can allow the hours sort of just drop off here. And I would use the equal ratio method here. And what did you get for your answer?
$420.
$420. Great job. Number 21, Joshua Local Bakery makes 4 muffins for every 9 croissants. If the bakery made 72 muffins, how many croissants would have been made? What was your proportion?
4 muffins over 9 croissants equals 72 muffins over X.
Good. Muffins over croissants equals muffins over croissants. You can do equal ratio method here, or you could cross multiply. What did you get for your answer?
162.
162 croissants. Did we get both of those correct? Excellent.
We both just missed.
Oh yeah, both of you had a little. Yeah, yesterday we seemed to have a little bit of struggle with those proportions. Seems like we've got it figured out. We just needed a refresher, I think, on proportions. We've gotten it. We're good on those now. Go across the page, excuse me, to page 498. Page 498. And let's continue practicing with factoring out common factors. I want you to do numbers 18 through 30, the even. 18 through 30, the even. Look for numbers that are common and or letters that are common, because you may have a little of both. Page 498. Numbers 18 through 30, the even. Once you've identified that factor, remember that factoring is division. You are essentially dividing that factor out to leave you with a remaining polynomial in parentheses. Take a few minutes to work on this. Again, just working the even numbered problems here. Good, Joshua. So since we're still technically dividing, we're still technically using sign, number, letter. Yep, there is no escape. Okay. All right, let's take a look. First thing you have to do is identify what's common. And always look for a number first. Joshua, is there a number?
No.
Okay, how about a letter?
A.
A. And that's all we can get, right? Not A to any power, just A. So once we've identified the common factor, put your parentheses, and we're going to divide every term by the A. Or you could say you're going to pull an A out of every term. And when you do, what's left in parentheses?
4a squared positive 8a negative 9.
Perfect. Lana, on the next one, what was the common factor you identified?
X squared.
And what did you get when you pulled an x squared out of every term?
Y to the fourth negative x squared y squared positive x to the sixth.
Perfect. On the next one, Joshua, what was common?
A 2. Wait, what? Oh, and an A?
And an A, both
I
a 2
didn't
and an
even
A.
see that.
Yep, so look not just for number, also look for letter. What should have been left in parentheses had you pulled the 2A out of each term?
1 x negative 1 y.
Good, or just x negative y would work as well. Lana, did you have that? All right, looking at the next one, Lana, what was the common factor?
5n.
Good, 5n is common. And what'd that leave you with?
7a negative 9b.
Good, so our answer is 5n times the quantity, 7a negative 9b. By the way, how can I check to see if I factored correctly?
We multiply the 5n by n.
Yeah, distribute back in and see if it works, right? If it comes back to what you originally had, you did it right. Now, that doesn't help you catch what Joshua had here where he didn't pull out everything common, right? So, want to try to find everything we can that's common. So Joshua, as we look at this next, we got a 36y to the 7th negative 12y to the 4th. What's the most commonness you can pull out? Start with the number.
12.
Good, 12. Not just 6, not 3, not 2, not 4. 12 is the biggest thing you can pull out. And
Yeah, y to the 4th.
y to the 4th. So pulling out the number 12, and they both have at least 4 y's. So we want to think like the government. How much can I get out of everybody? I'll take all I can get. Now the government has the mentality of if you're rich, I'll take as much as I can from you, and I'll take a different amount. But we're going to be a fair government and greedy, and we're just going to take as much as we can as long as we take the same amount from everybody. So we're getting 12y to the 4th out of everything here. Joshua, what should we be left with? Sign, number, letter.
3y cubed negative 1.
Perfect. 3y cubed negative 1. Remember, if you pull the entire 12y to the 4th out of itself, you still have the understood 1 remaining. Lana, did you get this answer? Great job. Looking at the next one, Lana, what's common?
9xy.
Good. You could say 3, but that's common, but it's not the biggest thing common. That's what we want is the biggest. So 9 and x and y. Lana, what's left?
2xy negative 1.
Good. 2xy negative 1 when you divide out that common factor. And for the very last one, number 30, Joshua, what did you identify as being common?
Yeah, probably completely.
Well, I'll tell you what. Ignore what you did on the paper. Let's get it right here. What's the number?
2.
What about a letter?
M squared.
Good. Get m squared is the biggest m. Can we take anything else out?
N cubed.
N cubed can come out as well. And what are we going to be left with here, Joshua? Sign, number, letter, sign, number, letter, sign, number, letter.
1 n squared n to the 4th. Positive 1 n squared. Positive 1 n. No n. N. Actually, no n either.
Very good. There's our answer, 2m squared n cubed times 1m squared n to the fourth, positive 1mn squared, positive 1 class. Do I have to write this one?
No.
No. Do I have to write this one?
No.
Do I have to write this one?
Yes.
Yes, this one I do. The other two I don't. But that of the last one, you better write the one or else, you lost a term. All right, Lana, did you get all of them correct? It seemed like you did. And then Joshua, we figured out there was something that we just weren't paying attention to.
Yeah, I was doing like kind of stuff like we did yesterday. I forgot all about
Looking for the letters. Except here where that's all there was a letter.
Yeah.
All right, good. And that's why we do them in little sections, right? Instead of do all of them at once, we just do a few because now we get a chance to come back and do a bunch of them correctly. Let's do 17 through 31, the odd now. So now that we know what to watch out for, 17 through 31, the odd. Bless you. Bless you again. Check your answer on the first one. Did you pull out just a 4? You really want to get an A, but there's not an A here. You can't pull it out if it's not there. You want to pull out a B, but there's not a B here. You can't pull it out. All you've got is the 4. Hopefully you got 4, though, and not just 2. What if, though? What if, let's just play devil's advocate here. You're like, hey, they're all even. I can pull out a 2. 4A squared, negative 6AB, negative 8B squared. This is not correct. It would distribute back, but you're not finished. But you know, you could easily get to this step if you realize, wait, there's still a 2. And you decide, well, let's pull out another 2. I've already got this 2. Now let's pull out another 2 to give me 2A squared, negative 3AB, negative 4B squared. And I just rewrite that as a 4. So, if you don't get, for instance, Joshua, in the last round of exercises, you missed the letter. Well, that's okay. That doesn't mean you have to erase and restart. You could just pick up where you left off and now pull the letter out in a second step. And it wouldn't have been wrong to do that. Well, how about this one? It's a pretty easy common factor, Lana.
3.
Just the 3, and of course that'll leave you with
1x squared positive 2x positive 7.
good. X squared positive 2x positive 7 inside the parentheses. Good to go on that one, Joshua. Look at the next one, Josh. What did you pull out?
W cubed.
Good. The W cubed is common. Now you could do W squared, but W cubed. You want the biggest thing. What's left?
1W to the 5th.
Ooh, should be a 15W to the 5th.
Oh, shoot. Yeah. 15 divided. Negative 24W squared positive 8.
There we go. And Lana, good to go there. Lana, on the next one, what did you pull out?
2x.
2x. Let's suppose, Lana, that you saw the x, but for some reason you forgot to check for the number. And so you just said x is common. What would be left if all you did was pull an x out?
6x positive 10.
And suppose as you wrote it, it suddenly dawned, there's a 2. Do we have to erase and start over? No, we could now pull out a 2. I've already got the x, but I can also pull out this 2 from right here. And when I pull this 2 out, what's left?
The 6x positive.
I'm pulling the 2 out.
The 3x positive 5.
And this is the answer you should have had regardless. Now, of course, it's way easier just to see the 2x, right? But even if you don't, even if you had to do it in stages, that's okay. How about the next one, Joshua? What's common?
11R.
Good, 11R. And what's left when we pull out 11R?
2R positive 3.
There we go. Good to go, Lana. On the next one, Lana, what's common?
7z squared.
Good, 7z squared. And when we pull out 7z squared, or factor it out, or divide it out,
2z squared negative 5.
there we go. And did you get that answer, Joshua? All right, on the next one, Josh, what is common?
3AB.
Good, a 3 and an A and a B, all common. When you pulled out that 3AB, what was left?
2x positive 3y positive 4z.
And that is correct, Lana, good to go there. And in the last problem here, Lana, what's common?
Positive, yeah, 3x squared 5.
Good, I see the 3, you're right, x squared, and y. Good, all right, and what was left?
1m squared and...
I think you're on the wrong problem. Number 31?
Oh, yeah, I am on the wrong problem. 4x to the 6, negative 6x squared y, negative 5y squared.
Yes.
Yeah.
All right, sorry, I was kind of doing it with you as you were reading out the answer. Good. Now, let's suppose for some reason we had fixated on, hey, I see there's an x everywhere, there's a y everywhere, there's a 3 everywhere. The easy mistake to make, right? I see the 3, hey, there's an x and y, and we just pulled out 3xy. What would be left if we only pulled out 3xy, Joshua? Sign, number, letter.
4x to the 7, negative 6 x cubed y negative 5 x to the, just x, y squared.
There we go. And here's what I want you to get in the habit of doing, because you're human, because on quizzes and tests, Murphy's Law comes true, right? Anything bad that can happen will happen, and at the worst possible time. You're gonna end up doing something like this probably on a quiz or test. So what you need to get in the habit of doing is, once you write your answer, before you move on, scan this polynomial and just see, is there anything still common? And what is, of course, still common, class? There's still an x in there, and it's, oh, there's one more x. Okay, so upgrade this to a 3x squared y, so we pull out an extra x. And now take the x, and it's a 4x to the 6th now. Now a 6x squared y. Now a negative 5y squared, and there's the answer that Lana gave us a moment ago. Does that make sense? So again, no need to restart, no need to erase, just check and make sure you got everything you really could. It's like the government coming through, well, maybe we can make one more tax. It seems like everyone still has a little bit of money. Let's take that too, you know? Anyway, a la communism. Questions on this? All right, look across the page now, page 499. I didn't have you do the entire homework section last night because I wanted to make sure we had a chance to practice some more in class before you did 12 through 19. So if you're going to do those problems at this time, page 499, 12 through 19. Bless you.
Thanks.
All right, let's see how we did on 12 through 19. What was your answer for number 12, Joshua?
5y times the quantity 1y negative 3.
Great job. 5y times the quantity of 1y negative 3. Number 13, Lana.
8y times the quantity 7x positive 6z.
Yes, 8y times the quantity 7x positive 6z is correct. Number 14, Joshua.
10z to the 5th times the quantity 5z to the 4th positive 3.
Great job. 10z to the 5th times the quantity 5z to the 4th positive 3. Number 15, Lana.
9cd squared times the quantity 3c squared positive 1.
Great job. 9cd squared times the quantity 3c squared positive 1. Number 16, Joshua.
2t times the quantity 2s to the 4th positive 1st negative 4.
Great job. 2t times the quantity 2s to the 4th positive 1st negative 4, or just positive st negative 4. Number 17, Lana.
12ab times the quantity 1a squared negative 3b.
Good. 12ab times the quantity a squared negative 3b. Number 18, Josh.
cg squared times the quantity.
CG 6.
I meant 6g
I figured you did.
Yeah,
It's Friday. We're tired.
times the quantity 5f squared g positive 2f positive 4g8.
Perfect. 6g squared times the quantity 5f squared g positive 2f positive 4gh. And Lana, you get the big one. But Josh's was pretty big too.
Yeah. 3g cubed h times the quantity 1g squared h squared positive 3h to the 8th positive 1g to the 5th.
Perfect. 3g cubed h times the quantity g squared h squared plus 3g to the 8th, 3h to the 8th plus g to the 5th. Did you both get all 8 correct? 8 for 8. All right. Well, you are doing well then with that. That's a good sign. Homework for the weekend is to do page 503. It's not. Page 503. Numbers 1 through 23, it's normal. Page 503, the homework section, numbers 1 through 23. These are quick, easy problems. We do have a test coming up in lesson 154. That's Wednesday. Test coming up on Wednesday. That'll be lesson 154. That'll be over chapter 10. So covering chapter 10. So we'll finish up our last... actually, do we have one more concept, or is it pretty much review? Nope, reviewing Monday, Tuesday, test Wednesday. So we've pretty much done with new material, reviewing Monday, Tuesday, test Wednesday, and then we'll move into chapter 11.
What is the problems that we're doing again?
Page 503, numbers 1 through 23 in the homework section. All right, have a wonderful rest of your day.